So let's have a look at sequences, specifically just nth term rule questions. So first one, we're going to have a look at the most common type. These are called ascending linear sequences. They're just going up. Let's see by how much they're going up. So from 5 to 10, we're adding 5. From 10 to 15, we're adding 5. And actually, if we carry that on, we would see that, yes, every single time we're adding 5. Now, you don't actually need to do this for all the terms you've got. Once you've done it twice, that's actually enough. Because you found out that there's a constant first difference. Maybe one more time would be okay, just to confirm. But if these add 5s are consistent with each other, then things are going well. Now, let's have a think. What sequence do we already know where we add 5 each time? Well, the 5 times table. 5 times table, well, that goes 5, 10, 15. Oh, wait, this is the 5 times table. So the way I think about it is the 5 times table goes up 5 at a time, and that has the nth term rule 5n. But just to confirm that you know, this is the 5 times table, and to have a method that works with any sequence, let's see how different our sequence is to the start of the 5 times table. So to go from the start of the 5 times table to our sequence, we add nothing at all. So you could write 5n plus 0, or you could just write 5n. They're both the same. Now, let's have a look with one that's a bit more realistic, a bit harder. From 2 to 7, we're adding 5. From 7 to 12, we're adding 5. This is also like the 5 times table. It starts with 5. It has an nth term rule of 5n. But this is not the 5 times table. The 5 times table doesn't start with 2. It starts with 5. So how do we get from our known sequence, the 5 times table, to our unknown sequence, the sequence that starts with 2? Well, we need to take away 3. So it has the nth term rule 5n, take 3. Let's have a look at some less common types of sequence than ascending linear sequences. So these are all more uncommon types. So let's have a look at this one first of all. One I've labelled number 3. Well, here we have some pictures. We've got 1 square, we've got 3 squares, we've got 5 squares. Well, this is a sequence, but let's just think of it, it's much easier to deal with it if we think of it as numbers. 1 square, 3 squares, 5 squares. So how do we get from 1 to 3? We add 2. How do you get from 3 to 5? We add 2. Oh, this is like the 2 times table. So it's going to have an nth term rule of 2n. But it's not the 2 times table, is it? Because the 2 times table starts with 2 and goes up 2 at a time. This sequence starts with 1. So to get there from the 2 times table, we have to take away 1. 2 and take 1. Now, some people, when they are learning about this, you write down loads of the 2 times table. Well, to get from 4 to 3, you have to take 1 as well. Sure, we've learned nothing extra from that. Don't bother writing it down. Let's have a look at number 4. How do we get from 22 to 17? Okay, that's gone down. How much by? It's gone down by 5. 17 to 12, it's gone down by 5. Oh, I don't know any sequences that go down by 5. Actually, maybe we do. The negative 5 times table. Well, that would go negative 5, negative 10, wouldn't it? Negative 15, and so on. And would have the nth term rule, negative 5n. But we don't need to compare to loads of this. We can just compare to the first term, which is -5 in the -5 times table. How do you get from -5 to 22? So from the known sequence to the unknown sequence? Well, we've got to add. So from -5 to 0, we're adding 5. And from 0 to 22, we're adding 22. 5 and 22, we're adding 27. Now, number 5 looks horrendous. We've got fraction, half, 3/7, 5/12, and so on. Now, what some people might start doing is they might start going, oh, well, that's 0.5, and this is, oh, this is horrible. That's not. No. If you have a fraction sequence, then we're going to have a fraction nth term rule. Now, you may have spotted that 1, 3, 5 is this and has this nth term rule. A numerator has the nth term rule 2n minus 1. What about the denominator? Well, you might have spotted that this denominator, 2, 7, 12, and so on, we're adding 5 each time. We saw here in question 2, 2, 7, 12. And this had the nth term rule 5 and take 3. Also, our denominator has the nth term rule 5 and take 3 as well. That's it. That's our nth term rule. You just work out the nth term for the numerator, nth term for the denominator, and we're done.